This video segment will go through the process of converting payments into shorter or longer periods. 3 examples will be shown. One where payments are split into shorter time periods, and a second where payments are combined into longer periods, and finally the situation where no compounding takes place until after multiple payments are made. So the first example here, convert quarterly deposits to monthly, and the NAR is monthly. It's going to be a 4% NAR. The quarterly deposits are $1,500 every 3 months. Months per quarter is 3. For 30, we want to find the future value in 30 years, so we're going to be working with months here, and that's 360 months. But our problem is we have a $1,500 quarterly deposit, and we need a monthly deposit. So we need to split that into parts. You split using the payment function. And to do that, since we're going 2 months, we need to have a monthly PIR, which is simply the NAR monthly divided by 12.33, many more threes percentage wise, and go down to the payment function. The rate is this PIR monthly. Number of periods, B7, 3. We want 3 months per quarter. So we're going to split that into 3 parts. There's no payment. What we have is that's the future value. I'm sorry. The future value is in B6. That's the quarterly payment. We're going to split that into 3 equal payments. There is no present value, but there is a future value. We combine these 3 and do the future value of the quarterly. And we put that together, you get a deposit monthly of $498.34. The future value of that in 360 months, we use B3, the monthly PIR, since we now have a monthly deposit. The number of periods is now monthly. It's going to be 360 in B5. B8, I can get it to click on there, is the payment, which is the $498.34, and the present value of B9 is 0. And we put that all together, and you get a future value of $345,870.52. Now we did this problem before where instead of converting the payment we converted the rate. Let me just go back to that. This is it here, and we converted the rate using the effect function and then quarterly. We went to a quarterly rate to fit our quarterly deposits, and we ended up with $345,870.52, which is exactly the same number we did here, which shows that you can convert rates or convert payments, either one, you can get to the same result. For the second example, move it up here a little bit, we're going to convert a monthly payment to an annual payment. So we're going from a shorter payment period to a longer one, and the NAR is monthly. Again, it's 4%. The PIR monthly, we're dealing with a monthly payment of $500, so we have to get to the PIR monthly, and we're going to combine 12 of those together into an annual payment. And to do that, you use the future value. You find a future value of 12 payments of $500 with a monthly rate of 0.33%. So at B18, it's a monthly rate, 12 periods. B19 is the $500, which is the payment, and the future value of those is $6,111.23. You do not just multiply the $500 times 12 and get 6,000, as that would ignore interest that you earn along the way, since there is monthly compounding. Now we can use that and find the future value. The rate, put this up here, B22 is the EIR, or the PIR annual. They're the same thing, so is the APR with annual compounding. So we take the NPAR monthly, use the effect function, we find the over 12 months that the EAR is 4.07%. So now we have an annual percentage, we have an annual number of years, and we have an annual deposit. So we can do the future value, plug it in, and you get 347,024 and 70 cents. Now as a check, we could do this monthly. Since we started off with a monthly payment, we know a PIR monthly is 0.33%, that's in B18. The months is B2130 times 12. The payment B19 is $500. You put that together and you get the very same number, 347,024 and 70 cents. We've done either way. Sometimes you want to do it two ways as a check. Finally, let's look at a situation where money is deposited, say weekly, but the compounding is monthly. So you may put it in the first week of the month, but no interest is going to be earned on that until the end of the month. So you may put in weekly 4 payments, but the interest is only based on what is the balance in the account at the end of the month. So we need to get a monthly equivalent monthly payment. So let's go through that. PIR monthly is 0.33%, which is 30 years, 360 months. Here's the trick, the $125 weekly. How much is that monthly? Well, it isn't just multiplied by 4, because there's 52 weeks in a year, and you divide 52 by 12, as this shows, you get 4.33. There's really 4 1/3 weeks per month. So we multiply the $125 and B36 by 52 over 12, 4.333, and you get an equivalent monthly payment of $541.67. Note we did not use the future value to include interest because no interest is earned on weekly payments because the compounding doesn't happen until the end of the month. It only looks at the month ending balance, not any balances in the middle of the month. So with that, we can put in a future value for 360 months and that payment, and it's $375,943 and 43 cents. So this is a little tricky. You have to think, is it going to draw interest in the meantime? If not, you do not have to use a present value or future value or payment function. But if it's going the other direction and you're combining quarterly, say, to monthly, making it smaller, then you do, and the NAR is monthly, for it's a smaller interval. If this was NAR is quarterly, it would not be the same. It would be like this third example. And that essentially goes through how you look at converting payments for different compounding frequencies. Thank you.